All right, let me try another solution here, back to chapter 15. And as I was trying to convey in a previous video solution, you might want to go back and look at number 42. Sometimes the best way to look at the standing wave ones is to kind of just draw the pattern. And I said in that last video, 42, sometimes it's best just to draw a bunch like this. Other times it's maybe better to draw what it might look like another moment in time so you can kind of get a mental picture of the evolution of time. So this would be a third picture and a fourth picture. And sometimes it's so obvious that that's the case and kind of confusing, not really realizing that that might be four different pictures in time. Sometimes it's best just to maybe just draw it and leave it alone like this. So whatever works best for you is fine. But I like to start off when drawing a wave, and then as it says here in 48, it says, how does the wavelength of the fourth harmonic in a rope with both ends tied? And the key here then is there's these magical points that don't move. They're called nodes. And since the rope is tied at an end, that end is automatically a node. So if you were just to kind of draw a line, you said, well, this is maybe the wall where it's tied. Just kind of ignore the rest of these. Okay? And so then if you say it is the fourth harmonic, so it says, how does the wavelength of the fourth, you would have to go 1, 2, 3, 4, and you would have something like that. And if the whole length between, one wall and another where it's tied, or tree to tree, or some kind of post to post, you know then that L would equal, and you can kind of look here, here's one hump, that's a half a wavelength, another hump, that's another half, and another half. So there's 4 half wavelengths, or 2 wavelengths, and you can probably see it better if I were to draw it, say, down here. Here is the one wall, so 1 hump, 2 hump, 3 hump, 4 humps, and there's the other wall. So we'll kind of ignore that over here, or ignore that over there. So this is what a fourth harmonic would look like, and you can see that that's one wave, and that's another wave, and that's what it's saying. The length is 2 wavelengths. Now they want you to compare it to, so let me just draw again, a standing wave pattern. How does it say it here? How does the wavelength of the fourth harmonic on a rope with both ends tied compared to that of the second harmonic? So the second harmonic would look something like this. This would be the edge, okay? And you would go 1 hump and then 2 humps. Now, that almost looks like I made it closer together, so maybe I should realize that the second harmonic would still be just as far apart, so it would be L, but it would only have 2 humps in it. And so that would be saying L would have a hump and another hump. So that's 2 1/2 wavelengths, or just 1 wavelength. So this up here is saying that the wavelength is 1/2 of the length. And this one here is saying the wavelength is equal to the length. And so that is really saying here, and here's the answer, that the wavelength, and so the lambda of the second harmonic is twice, 2 times as big as the fourth harmonic. Or maybe the other way around. The second is, the second is twice as big, or the fourth is half as the second. So you can just kind of see that, the fact that you got to get the same spacing. Here has 2 humps. The same spacing has to have 4 humps. These have to be closer together by a factor of 2 to 1. All right. Hope that helped.